Hello, I'm David Nolen, and this talk is called Functional Programming in the Cloud, or Simpler Application Development with Datomic Cloud. Full disclosure, I'm a software engineer at Cognitect. Cognitect created Datomic and Datomic Cloud. It's a product. What does Cognitect do? Cognitect is a software consultancy. At Cognitect, we believe that there's a lot of incidental complexity in software development, and that one way to manage the amount of incidental complexity that exists is to sort of embrace immutability, which is kind of like one of the big ideas around functional programming. At Cognitect, besides Datomic and Datomic Cloud, which is our product, a lot of what we do is just work with people on their software problems. They have a problem, and what we do is we take Clojure, which is a functional programming language for the JVM. It was created by our CTO, Rich Hickey, about 10 years ago. And Clojure uses immutable data structures as a core design in the language, so that allows you to build systems with much less state. You actually end up building the exact same kind of software you built in the past, but you build it with less state. You build it with more reasoning power, again, because you've built a simpler program, right? There's just less state to think about. At Cognitect, the other open source thing that we do besides Clojure is ClojureScript. I'm the lead developer of ClojureScript. I've been working on that for about 7 years now. And we took all of the persistent data structures. And by persistent, I don't mean persistent on disk. I mean in the sort of functional programming language sense. Data structures which are performant but immutable in design. And those were all ported to ClojureScript. And modern JavaScript engines are fast enough to deliver really great performance. It's not something that people care about too much. And in fact, when you tie this in with React, one of the things I'm kind of known for is that I demonstrated back in 2013 that you could take ClojureScript and ClojureScript's immutable data structures, and you could be twice as fast as React out of the box. And that was sort of counterintuitive, and people got interested in that. But anyways, so I'm not, we do Clojure, we do ClojureScript, and we do Datomic, and in a sense, this is meant to be a pitch for any of these technologies. These technologies, I consider them to be tools and sort of possible solutions to the problems that we actually see in the course of software development. Hopefully, in this talk, you can listen to what I'm talking about in general and see that Clojure, ClojureScript, Datomic are specific instances, but maybe you can take the sort of design philosophy and sort of the problem approach and use whatever set of technologies you believe are best suited to your particular case. One of my favorite talks that Rich Hickey has given, he has many great talks. I think the one that everybody should definitely see is one called Simple Made Easy. It's really, really good. But the other one, which I think is slightly less well known, is this one called Hammock Driven Development. He presented this at the very first Clojure conference in 2010. And when I revisit this now, I mean, back then I really liked it, but now when I revisit it, it's a really, really, really great talk. Because the thing that he emphasizes, to me, the key takeaway is that in sort of software practice, and I encounter this personally, but I also see this when I encounter projects that are struggling, is that a lot of the struggle often comes from a lack of spending enough time describing the problem. Often at Cognitect, when we're working on something, Rich is like, have you thought about the problem? Have you written down your thoughts about the problem? Have you explored the alternatives? You only have one answer. You have a solution, but there's only one. Why aren't there at least two other solutions in your ideas of how you might solve this? And then for each proposed solution to the now well-described problem, have you enumerated what are the various trade-offs associated with these things? And to do this, it's not possibly completely objective. That's not the goal. The goal is to go through the process, document it, and then have another set of eyes, preferably more than just one other set of eyes, go and say, oh, I agree, I disagree. And then at the end, you'll be able to make a reasoned and an informed decision. I definitely think I've seen many cases where, okay, I see something that happened, and now that's embedded in the system. It's a bad fit. And you discover that actually it was never documented how that choice was made, and it seemed like the choice was made very quickly, and now you have to live with that decision. And it's surprising how often these things can snowball into bigger architectural issues. So I want to talk about the language of problems, not the language of solutions. Again, ClojureScript is a solution, Datomic is a solution, but let's see them through the eyes of the language of problems. All three of these sort of technologies, products, they're all oriented around, I would argue, this paper. This was recommended to the Clojure community by Rich, now almost 10 years ago. It's called Out of the Tar Pit. It's by two Haskell programmers, Ben Mosley, Peter Marks. And these two Haskell programmers are trying to understand, experienced developers, and they're developing in Haskell. We're writing in Haskell, but they still have engineering issues. Where are the engineering issues arising? Where is the complexity in the development process occurring? And they come to a very interesting conclusion. It's funny because they're actually sort of responding to Fred Book's No Silver Bullet. And he says there's nothing. And actually, they say it's not that there's nothing that causes problems in software development. There's not one. Fred Brooks argues there's no one major place. And Ben Mosley and Peter Marks are making this claim that there is actually a very large source of complexity. And they try to build a case for it. And I think it's pretty convincing. This is, I think, an essential read. It doesn't really matter if you like functional programming or not. They come up with an answer to this problem. It's called FRP. It's not FRP that you've probably heard if you go to tech conferences. The hot thing these days is functional reactive programming. You've probably heard of that. But they're talking about functional relational programming. And what they're trying to show is down from the data model all the way to business logic, all the way from the moment you sit down to do your data model up to the point that you have business logic and you have to run queries, where are the places that traditional mainstream software development introduces state, and can we eliminate it? So FRP is sort of like a holistic elimination of state at each level of the architecture during the process of designing your system. It's very compelling, but again, it's also a kind of solution. The more interesting thing is they've identified a problem is that state occurs in more places than we believed. By going through this process, they found more places than they thought they needed. And in the end, they come up with the design, and their conclusion is, which is an interesting conclusion, is actually all the places where we thought we needed state, we didn't need it. And in fact, we designed a whole thing to be as pure as possible. And when we reintroduced state, the only places where we did it were the places where we needed performance, caching. And so what this meant was that, we have a completely functional, easy system to reason about since the flow of data is only in one direction. And the only time we have state is when we need performance, which doesn't semantically change anything, right? It just makes it faster. No semantic changes. And that's something that I think that's really the real struggle is once you introduce state, often semantic changes occur and they're hard to track down. So again, what's the problem? And I think they do a great job of enumerating this. It's a 30-page paper. It's a great paper. And that stateful programs are surprisingly hard to reason about. Even if you've been doing software for a very long time, I think time and time again, you see something and you're like, well, how did we get here? And there's no direct flow to understand how you got there. You're going to have to dig around and see how state changes allowed you to end up where you ended up. Okay, so that's an interesting thing. But their paper, and it's also my experience, that one of the biggest challenges when you're talking about this stuff is getting other developers to see the problem. In fact, it's very common that the problem is invisible. Or if it's not invisible, then the other thing you encounter is that people don't think it applies to them. Right? That's also very common. So I actually think in the mainstream, people often say, stateless is better. Stateless is better. And then you go and look at somebody's code base and you're like, well, don't you know this phrase, stateless is better? But yet, many components in their system have state, even though it's something that's basically like a proverb, right? Stateless is better. So we often have trouble sort of seeing that it's just a different version of a problem that we already know about, and there's a well sort of researched answer. So a specific case of this actually is, a good case of this is React. So again, I was an early proponent of React. And when React first came out, people obsessed about the sort of I would call surface details. It had XML literals, but for React, I mean, sure has XML literals because I think it's a good idea. But is that what React is about? Actually, in the end, no. React, when it came out, was widely ridiculed, and I posted about it. And I said, actually, it's really cool because it's the first time I've ever seen something from the JavaScript community work with a functional programming language. So I was able to do a seamless integration with React in like a couple weeks. And I was like, this is actually a new approach to UI development, which is radically different to what we were doing before. And I think that I think it's better. I mean, I'm convinced it's better because it addresses the actual problem, which is that we incidentally have a lot of state. and we didn't have I would argue, a convenient enough abstraction to allow us to write mostly stateless UIs, right? This would have been challenging to do with any of the traditional things, or it would have seemed unidiomatic, whether it's Angular, Ember, whatever, right? They're all the same in that doing things in a functional way is challenging because those technologies don't embrace functional programming as a inherent value. The beautiful thing about React is now, like, React is easily, on current surveys, it is by far, by a gigantic lead, the most popular framework. And I would argue that people only have a sort of passing understanding that the reason that you like it is that it's functional, right? So people have become functional programmers, and an entire industry has sort of transitioned to functional UIs, but nobody's really banding about the terminology so much. And that, I think, is very interesting. Because again, it's not the sort of jargon that's important, it's that what was the problem? The fundamental problem was that stateful programs are hard to reason about, and React helped us see that applied to UIs as well, right? So people had long argued that UIs are object-oriented. It's an object-oriented thing, right? It's a bias that goes back all the way to Smalltalk, right? It's just a bias, and it blocks you from seeing the reality of the situation, that there's nothing about UIs that was particularly object-oriented. And React sort of completely dismantles that idea completely. Like, you can do completely functional programming with React. And in fact, React just came out with this thing called React hooks. You don't even need classes anymore, right? So before, React kind of forced you to do, like, if you wanted to do like these sort of like custom components, you had to make a class. But now you don't need any classes at all. You can write a completely, fully functional UI functionally, without any sort of object-oriented things at all. And again, it's not about object-oriented things. It's really about programming things in a sort of stateless way. Which brings us to Datomic. So where does Datomic fit? So I sort of talked about back-end things. I've sort of talked about how React is addressing a problem. It's not the only answer, right? People obsess about React as the answer. I say, no, React just shows us that we didn't see the problem. Right? We didn't see the problem. So Datomic is a similar thing. When I talk about Datomic, people are always like, I kind of heard of that. That's that weird database, right? That the Clojure guy did. And then I say, yeah, it's an immutable relational database, and people scratch their heads and like, well, why would you need what's that for? And again, because we're so used to writing systems that use mutable databases, which are effectively a giant global mutable variable in the cloud. You've never even thought, what happens if you replace the mutable variable in the cloud with something that looks like a giant immutable value? Basically, you get something if you like the idea that if you think that Redux is an interesting architecture, there are things that I don't like specifically at Redux, but in a big picture sense, Redux is interesting. What if you could build an entire end-to-end system, right? Completely functional, the whole thing, all the way to the point that you write to the database. It's completely functional. That's the idea behind Datomic. Again, what's the problem? In that even if you embrace these sort of functional ideas in the front end with ClojureScript, with Elm, with PureScript, with JavaScript, right? You can do this stuff with JavaScript immutable JS, or you decide we're going to use JavaScript objects, but we're going to be more careful. Whatever. It doesn't really matter how you do it, but if you think that's a good idea and you adopt this approach in the back end, eventually you bottom out that we have to write to the database, and that database is going to be Postgres or Mongo or whatever, and it's just a mutable thing, right? That becomes the place where, okay, how did this happen? And now we have to go fix the database because somebody messed that up. So Datomic in a nutshell, I could talk about Datomic for a long time. I've given 16-hour workshops on Datomic, so I can't talk about Datomic for that long. I'm just going to do a high-level overview. I'm going to show you a few interesting things at a REPL. That's it. But hopefully, it sort of piques your interest. So Datomic, it's an ACID-style relational database. Unlike SQL, MySQL, or Postgres, the query language is Datalog, which is yet another old thing from the 70s, which is very cool. It's a better fit for Datomic, and you'll see that. It allows us to do pattern matching, which is really, really great because the way that Datomic works, that makes sense. Information is stored as facts. So you don't define tables. Like when you make tables, you have to define all your columns. You have to add columns, drop columns, whatever. It's just table-based thinking. Datomic says there's a universal representation for anything that we want to describe, and that's called the fact or the datum. And that's entity, attribute, value, time. If you come from the sort of like semantic reasoning world, you're familiar with RDF. Very similar. It's a triple, but in our case, we add one more thing, time. This is the immutability aspect of Datomic, right? So anything in the world can be described with, you're talking about some entity in the world, you want to describe a particular attribute of that entity, and what is the value of that particular thing. We add T, and I'll describe that more in a second. So if I want to describe somebody's first name, something exists in the world that has an attribute first name, and that thing's first name is David. Of course, entities, the same way as you would be in a database, the actual entity is just a number, right? It's just a long, right? It's just a number, some ID. That represents that person. The novel thing with Datomic is that actually Datomic, when you add a fact to the database, it adds logical time to when that fact was added, right? So if I add an address, my address to the database, and then today I move and I add that new fact, it doesn't erase the fact that my address was something else before, right? I query for my address, and of course look at the most recent one, but I can always query for yesterday's address. Where did David live yesterday, right? There's no work that anybody has to do this, because Datomic never erases facts. Datomic only adds facts, and it includes logical time for when the fact was added to the database. Again, just to reiterate, you can represent any relationship with this triple model, right? If you're familiar with RDF, you know this already. If I want to add a last name, I can do that. If I want many-to-many relationships, one-to-one, whatever, all the typical things that you're used to work. Datomic has all the normal stuff. You can do negation, disjunction, yada, yada. It does all the things that people want and they like. The one thing that it does that I think is a great fit for modern software development is that people are starting to realize that being able to do graph-like queries, which is a bit tedious in traditional databases, but elegantly described at the API layer by something like GraphQL, right? So Datomic, because it's data log, it's able to express these graph queries very naturally. It's just fundamentally a part of Datomic's design to be able to sort of query a graph and say, give me the value of the trees of values that this query represents. And then you can immediately render that into a UI. That's exactly, which is precisely why people like GraphQL. So here's a quick demo. Hopefully this works. Oh, wait, except I need to get on the network, though, right? Do I? The second one? Second last? OK. Hopefully this works. OK. So here I'm in IntelliJ, so Clojure. If you're not familiar with Clojure, it's OK. It's not about Clojure. I just want to demonstrate the semantics of Datomic. That's all that really matters. I'm actually talking now directly to AWS. This is using Datomic Cloud, which we're going to get to in a second. So I'm just going to show you everything I'm doing is just talking directly to AWS. My profiles and my keys are all set up. And this is how I think dev could be. This talk is really about cloud-first style, cloud-native style development. I don't run a web server, right? I just program directly against AWS. If I need to do web stuff, I'll just make a Lambda and I'll expose it via API gateway, which means a whole class of things that people normally do when they make web services just goes away. I only do business logic, write queries, and then I might write some Clojure script to do front-end stuff. So here's configuration. It's inline just because, for simplicity's sake, I'm going to make a database. I'm going to connect to the database. I'm going to transact a schema, but let's just look at this really quick. So the schema, just to show you what it looks like, it's just like you can just say there's an attribute, it exists, it's the type of string, it's a cardinality, I can document it. There's a thing that we don't really care about. There's last names. People have emails, cardinality many, right? I can have many emails. People have telephone numbers, cardinality many. It gets a little bit more interesting with, OK, I have an address. An address is not one thing. It points to many things. An address can have a street, a city, a state, zip code, so on and so forth. But I'm just showing you that the schema allows me to do the traditional sorts of modeling that we're used to. OK, so I'm going to load that schema. And that's in the database now. I'm going to load some initial data. And then here we're going to see our first instance of what does a Datomic query look like. I have a connection to the database. I'm going to say, I know there are people, entities out there. I know they have the last name attribute. I want to assign that to a variable, ln for last name, and just return all these values. And that's, in the current data set, it's returned all the last names, just like you would expect in SQL. I can say things like, well, I know there's a person in the world who has the first name Kovas. Get me his last name and include the entity ID, which is just like a database ID, just like in MySQL or Postgres. I can parameterize the query, right? So here I've inlined it into the query. So here I'm saying find the entity with the last name where that person's first name is Kovas, where their last name is something. I bind a variable to that. Here I can parameterize it where I say I don't want to specify Kovas in the query, right? I want to find a person. I pass this as a parameter to Q, and it says here bind this to this argument. This is bound to the first argument. That's the database. This is the last name, and I say find that person, find that entity. And then I get this ID. I'm going to copy and paste it here. And now I'm going to say, I'm going to use this thing called pull, which is like GraphQL. So pull lets me say, I want a nested series of attributes, and they can be arbitrarily deep. Get them for me. I'm going to do a flat one first. And notice this returns a record. So I'm not getting tuples. I'm getting back exactly what I would render into an application, like a component. Right? I get back, this could be trivially converted to JSON for rendering. Down here I can say, I have a person, I want their first name, I want their last name, I know they have a reference to an address, and I want the city. I only want the city from the address. And then here, first name, last name, address, and that city is Brooklyn. Right? This is the type of thing that you expect from GraphQL at an API level, but Datomic gives it to you as a fundamental feature of how you can query the database. Again, this talk can only be so long, so I can't spend that much time on all it can do, but suffice to say, Datomic does all the things that you expect from databases, but it has, I would argue, many, many modern features that are, again, a bit of work to get from existing databases. So here I'm going to make a helper function called all names. But you could imagine I'm writing an endpoint that's going to return all names or something that's parameterized, whatever. So I'm showing you, I'm just doing dev locally, but it would be a trivial step to synchronize it to the Datomic cluster and then expose that over Lambda and then just be like, oh, I can just talk to that from my JavaScript client. So it's just a function that returns all names. I'm going to do this very funny thing. I'm going to say, from the connection, give me the database as of now, right? So that's what I said was that every time I record a fact, a logical time is recorded for it. So I can say, give me the database that represents that logical moment in time for that database. Like, give me the value of the database at that point in time. So here I'm going to say, this is just a function that returns the current date. Give me the database of that date, and this is the now DB right now. And then I'm going to query that database for all the names that are currently in there. You got some names. Here I'm going to just make some dummy data. I'm going to add just a fake person into it. And then let's clear this. I'm going to say, give me all the names. And of course, that new person is in the database. But that doesn't change the past, right? I mean, the immediate thing is, of course, the obvious thing here is you can now say, I can query the past. Somebody has a question, and they're like, oh, the data changed, but it doesn't matter, because I can always query the past. I don't need to recover anything via logs. Fundamentally, the database always knows how to travel back in time. If you're doing analytics, you could even say, I want to window this time. I want to actually move the front of the time to this point and this way, and then just run a query on a subset of the data. Of course, that's really great for analytics. I mean, the customers that like Datomic, of course, really care about the fact that they get all this analytics power for free directly from the database. But if you're a programmer, what's the benefit of this? I mean, you could of course say, oh, this seems esoteric. I don't see what applications this fits for. But actually, a very common thing is you make an error in your source code, you make a mistake, and something happens in the database. The data is corrupted, and you need to understand what went wrong, right? So an easy way to do this is you get reset to that point in time, go back to that source point. You know the time that you committed that thing. Datomic, recover the copy of the value of the database when you made that source change, and then figure out the bug. Like all the ceremony that you do around fixing the database, trying to make sure that things are the same, all that stuff goes away because you can always get to exactly what the database was when the error was introduced. And that's actually one of the biggest value propositions, is that it just changes how you think about using your database. The database is no longer an enemy. The database is actually now very much a powerful development tool. Again, because what did we do? We just said there's a problem. Databases are global variables. What happens if we stop doing that? Okay. So again, powerful auditing capabilities. Hopefully that made some sense. Another thing I don't have time to talk about is the transactions are actually queryable. So every time you transact into Datomic, it actually adds a fact of that transaction, so you know all the datums that were added. So again, for like auditing, when something bad happens, it's very easy to say, query all the transactions that involve this entity, perhaps this user, where something went wrong. Pull syntax, as we've shown, it makes it very easy to express graph queries. Again, they can be arbitrarily nested. And I think that as people begin to understand the value of a GraphQL design over a RESTful design and what benefits it adds, I think people will find this story much more compelling. It's certainly the case that in my experience, having worked on a few client projects with Cognitech where clients are using GraphQL, it's much, much nicer than the RESTful projects where people were returning like giant payloads. The client doesn't need any of it. GraphQL really allows clients to pick and choose. Again, it's not about whether GraphQL is the answer, but GraphQL does solve a problem that we actually have. So Datomic Cloud. So everything I was demoing was actually Datomic Cloud. I was not running Datomic locally. I've provisioned Datomic on AWS, and I was talking directly to AWS. So people often ask this question. Datomic actually, we have an older version of Datomic called Datomic on-prem. If you want to run it on your own thing, you totally can, and a lot of people do, and that's what they want. But consistently, people were like, running your own stuff is a lot of work, right? In the end, doing ops is not that fun, and you have to. It takes a long time to build up expertise, right? And it's my experience that same way you want to hire somebody who's done MySQL or Postgres for 5 years at least before you have them on your team, especially if what they're going to do is mission critical. Datomic is no different. It really takes a long time to become an expert at how to operationalize Datomic. And so Datomic Cloud exists simply because a lot of people don't want to manage it. So Datomic Cloud, all we did was everything's the same as it was before, the data model, the immutability. But now what you do is that it's a marketplace thing. We provide an AMI, and you don't have to manage it. In fact, you just click a button, and the whole thing's set up. And it took me, I think, I set this up yesterday, and I hadn't done it in like a couple months. It took me 15 minutes. 15 minutes to click through the buttons on all the screens and go through the tutorial to have Datomic running in AWS. So there's just an ease here, automation. The other thing Datomic Cloud gives you is it does auto-scaling. So if you want the production, it's called the production topology. If you want that, and as load increases, both the DynamoDB tables that are used for storage as well as the cluster will scale with the amount of activity that you have. So you don't have to manage that at all. So that's really what that's about. But that's sort of like that's the part that people like to emphasize, the scalability. But I actually want to focus on something different, which is why do I think Datomic Cloud is interesting? Which is a very different thing, which is that I've been doing cloud stuff since the New York Times for about 8 years. I've been doing stuff on AWS or sort of cloud-related things. And my opinion is that, you know, what's happened with software development, it doesn't really matter if you're using Clojure or Python or Ruby or JavaScript. They're actually all the same. Because when I sit down to write a web application, generally I have to pick a web server, pick a router, pick logging, pick a database driver, pick a database. Then I have to decide where my assets are going to go. Figure out which plugins I'm going to use for those assets. There's all this stuff that you end up doing. And none of those things actually have anything to do with the thing you want to write. You just have to do it to get there, right? This is a bunch of stuff that you just have to go through. It has nothing to do with the actual work that you need to do. And it's my opinion that especially when it comes to cloud, people have become obsessed with local dev. And I'm not saying that what I'm proposing is an answer. My idea here is what happens if you stop caring about local development, right? In the end, your thing is going to run on AWS. Why do you care about local development? And every project I've worked on for the past 8 years, people obsess about, oh, local dev, local dev, local dev. And it doesn't really make any sense because in the end, AWS provides usually better versions of everything you would do, whether that's authentication or parameterization, reading environment variables, whatever. Right? AWS has all that stuff, logging, metrics, right? It has everything. And yet people roll up all this stuff. And so my question here is with Datomic Cloud, what I've seen is that what happens if people build frameworks that are just cloud first? You're just always programming against the cloud. You never do, you just local. Who cares about local? The only thing you do local is client assets. JavaScript stuff is local. But everything else, remote. Web servers, all the database stuff is remote, just from the get-go. It's actually not that bad, as I demonstrated, right? It was IntelliJ talking directly to AWS. It's not that bad, right? I'm sure you've seen this GIF before, right? Like, this is what web dev feels like. I've set out to do X, right? And then, it's just thing after thing after thing after thing. And I think this is quite common. I've definitely seen this in my own projects when I start, but definitely with client projects as well. You're just sort of running around, never getting to solve the thing you actually want to solve. We'll watch that. That's pretty good. The other thing is that I also think that cloud dev is also something else that I've experienced. That cloud dev is also, it's definitely a productivity killer because a lot of the tools that we have, what we do with cloud is that we say, oh, why do people want local dev? What I've observed is that people like local dev because they think cloud is slower, and that's usually because you have to go through some crazy build to get to the cloud. Not because cloud is actually slower, right? It's because I have to run the entire staging thing before I get to see anything. So that's going to take 5 to 10 minutes because I have to wait. But if you just said, well, let's just have all steps just be there, what's the big deal? And I think that's really the thing that's gone wrong is that we think that it's slow, but I don't actually think it's that slow. So this idea, this sort of thought experiment, the Datomic team sort of actually ran with this thought experiment. What happens if you just unravel people's sort of preconceived notions about cloud development, and you end up with something, I think you would end up with something like ions. There's actually very similar initiatives in the JavaScript world. I think the JavaScript world is very good in this way. There's things like run, to a degree, the notebook stuff, but really I think run is closer to what you want. You really just want to be like, I just want an easy way to deploy the thing. The only thing that run is missing is like database. But that idea of I just deploy, like it's just always there in the cloud. It's an interesting place to start. So Datomic Ions is a feature in which, so when we deploy Datomic, when you sort of start it up via AWS, a Datomic cluster is created. So all Ions do is it says, well, what if we had a thing where you could take your Git closure repository and simply get that into the cluster? So your code runs in the Datomic cluster. It'll get replicated to the cluster. And now you can just update it that way, right? So now dev for me would be, oh, I write a function. I talk to AWS. It works. I hit deploy. That makes a git SHA. That actually makes what's called a code deploy revision. So if I need to roll back, all the things that people like with agile deployment, you commit a thing, you push it, broken, code deploy lets you go backwards. That all works. So Ions is just a way to get your code into the cluster to run with Datomic. So again, code deploy gives you rollbacks. And then you can literally say for each function, I want a corresponding lambda. So that looks like this. So this is their tutorial. So here's some functions. Like I could have, just like I demonstrated some function called all names. You can just say what the functions are. These are the functions that are allowed to be exported via lambda. And then down here, for each entry, you have the function that you want to map to a lambda, and then just a description of what that is. And so in this case, I'm not going to write any web servers. I'm not going to do logging. I'm not going to do routing. I can do all that stuff in AWS. I don't need to do permissions. All that stuff is AWS, right? There's almost nothing in this file because all the things that we used to have to do, they just disappear. Because all I really care about is my app logic, my business logic, my queries. Okay, client side. And so, a lot of this, the reason I'm excited about this is because I'm coming from the client side perspective as well. Like I was doing front-end development for, I'm still doing front-end development. So I've been doing front-end development now for like 14 years. And so for the client side, you can just develop locally, right? So you can just write JavaScript, and the JavaScript simply talks. And you can use, AWS has a JavaScript SDK. If you need to authenticate, just use those credentials. Don't stick them in the source files, and you're good to go. If you need to call into the functions that you wrote, you can use the AWS JavaScript SDK, talk to Gateway, talk to Lambda. That will just work. So again, that's the big idea. Again, for me, the problem is, I believe here is that we can't see that the cloud actually is giving us a very new way to think about doing software development. And the problem is that, again, we've really created a lot of ceremony on how we get applications up and going. And I think it's counter to what technology is available and what that technology is able to let us do. So again, the idea that I'm proposing here is you can dev for all client stuff that can be local, but there's no more booting servers or any of this stuff. Your server's always on. It's protected via IAM. There's just all the things like starting servers. That's just done. Server is just always on AWS. Of course, the first question is, how do you partition this? Really, on the Datomic side, it has this thing called query groups, which answers that. You want to do testing, staging, production. For your local dev stuff, AWS has an answer to this. You can host websites on S3 buckets, right? And if you care about hiding that stuff, it's very trivial to make an S3 proxy. That's something that people have been doing for a long time, right? So many steps, I think, disappear if you just do this sort of simplified model. That's actually it. I went actually maybe a little bit faster than I expected, but maybe that gives me time to answer lots of questions. Thanks. So the immutability is really a benefit for, like, there are two parts, right? I mean, I sort of focus on immutability because I'm trying to describe the value propositions that Datomic and Clojure give, and those are applicable to other languages. Then, of course, the end is just like, okay, Datomic has this new thing, which I think is bigger than Datomic, which is what happens when you think about cloud native development, where you stop thinking about local being important and say, what if you just code directly against the cloud? That, I think, is something I don't see that as an approach. The immutability thing is really about making your UI simpler, making your backend code simpler, like more discrete. I think the cloud native thing is definitely more about like simplifying the sort of whole architecture and the sort of dev workflow. It is not open source, not open source. So Clojure script open source, but Datomic is closed source commercial database. Yeah.
So you showed some examples of the data log queries. Is it possible to store the query just inside of Datomic, or should I always keep a copy of those queries in my database?
You could store the queries in Datomic, but I don't necessarily see why you would want to do that. I mean, people. I would not be surprised if people have done that before. But I've never done that. I mean, to me, if the queries, I mean, I see what you mean. Maybe you want to get at the old queries, but it's in version control, so I don't, you can get at them, but not necessarily as data, which is I think what you're trying to allude to.
How do you delete, say, David Nolen from the database?
So you. So there's a feature which we don't recommend unless you need to comply with stuff like that, and it's called excision. So excision will actually truly delete. It's a very special thing. It's truly destructive. It's not something we recommend using. That will delete it. The thing that we do recommend for normal usage is something called retract. So I may have an email, and I'm like, that's not my email anymore. I'm just going to retract it. And that just means further queries, that data won't appear. However, if somebody runs a query on like, what were his emails yesterday, it will appear again because it was true yesterday, not true today. So retraction is the typical application style. This is no longer true. For compliance, excision exists, but again, that's truly destructive. I'm not, but
I see you can run through the entire Git history, and on each commit you can run a shell script. So you can convert every commit or whatever you did. So typically if you want to remove something from Git,
yeah, you have to do something like this. So I'm sure that internally it works like that because again, there's many often when it's like a technical thing, which is maybe of interest. So the way that Datomic works is that we work over key value stores, and it's what we do is like it's really like if you know anything about persistent data structures, it's really cool. All we do is we take basically 50,000 datums, and it's like these like 50K segments, and we know because we know the path where that's going to live. That lives in the key value store, and so when we look something up, we know how to find by hashing an integer, we know where to find it in the key value store. But what this means is that if I update even one datum, we're going to copy all 50,000 datums, update the one value, and then rewrite that. So there's often multiple copies of the data. So Excision is something that is aware of this problem, and then we'll go and do all that. I did that. I can do it again. Yeah. So here, I recorded nowDB, right? I made sure to do that before I added this other person. So here in the nowDB, the previous DB, the original DB, foo1 bar1 is not in there. They're not in there. And this hasn't changed as long as my okay, that didn't crash. Okay, so I can show you again. So if I run this. This is still that one. Now, actually, let's do this. All names. So let's do this. Whoops. So let's do now. Let's record this one. So now, right? So all names now 2dB. Whoops, I didn't define that. Oops, not db2. Thanks. So it's there, and then if I go like this, and then I check this one, there's 2 new people. I check this one, there's only that one, and then it's the original one. Yeah. Yeah, I'm sorry. Yeah. It's true. Then DB. It's true. That would have been better. Naming is important. The schema is required because we do need to know the type of the thing that you're going to write into the database, because we have a it's like a compressed data format. So we actually need to know the type of the thing you want to write. Like, is it a string? Is it a float? We do need to know that. It is very open-ended though, but we need the schema. It's still in some sense less restrictive than like a sort of a table thing, because you can always transact schema. If you decide that people now have middle names and you were like, oh, we messed up, we forgot middle names, it's no big deal. You don't need a database migration for this. Right? You just add that new thing to the schema, and now you can have middle names. Well, so again, it uses this thing. Oh, wait, I'm blanking. There's a format that they use. Freshen. So there is a compressed format, but in the end, no, they're actually customers upward who have more than 10 billion datums, and it's just you just pay for more storage. No. Yes, absolutely. Is more important than the cost of storage. That's correct. Yeah. Right. Right. Other questions? The queries, like the queries would just be in the source code, right? Same as the queries in your source code now. There's nothing novel here. So nothing I'm describing is recommending talking to the database directly from a JS client. And nothing I said recommends that. Yeah, but no. So you can't. So for security, you have to consider that in all the usual ways. All the usual ways. All right, cool. Thank you. Oh wait, one more. So it's actually been proposed. So one thing that people are really excited about is because the Ion infrastructure is generic. It doesn't have anything to do with Datomic. It's Datomic agnostic. The whole thing of running a cluster and auto scaling the cluster, it's all just generic stuff. If there's enough interest, Rich and Stu, who create, they work on Datomic, and they're sort of driving it. They've said if enough people express it, then they would offer this as a sort of a service which just provides the architectures to scale in AWS, and you don't have to think about any of that stuff. So great question. Yeah, it's definitely under consideration. Cool. Thank you, and feel free to ask me questions later.